Hello everyone, welcome to another particular lecture of conformers. So in our previous lecture, we are discussing about the acyclic conformer in detail. So in this particular short lecture, we are talking about cyclic conformers. So the basic difference between acyclic conformer and cyclic conformer is acyclic conformers are basically we are learning about the long chain molecules like ethane, propane, butane, and here cyclic conformer we are talking about cycles like cyclohexane, cyclopropane, cyclobutane, cyclopentane type of things. And in the case of acyclic conformer, only the van der Waals strain and torsion strain present. But in the case of cyclic conformers, two new strain has been introduced. That is the angle strain and ring strain. Okay, so let's begin with our basic cyclic system. That is the cyclopropane system. So here you can see the cyclopropane system where the all the carbons are sp3 in nature, and as you know that the bond angle between sp3 carbon is 109.28 degree, but due to the presence of this particular ring formation, the bond angle is squeezed to 60 degree, and due to this sudden squeeze this particular bond angle, so this particular ring actually exhibits the uh, greater angle strain that contains a high angle strain, and that's why this particular cyclopropane compound has found to be very reactive in nature. And due to this particular thing, these two bonds are elongated due to the higher p character. Okay, and this particular content has a more p character, and these bonds are poorly overlapped, and hence this is the reactive. And this particular structure, if you see cyclohexane, here all the hydrogen has their own eclipsing interaction. Eclipsing interaction, as we know what is eclipse structure is. So this type of eclipsing interaction is there. So for this hydrogen it is 2, this hydrogen it is 2, this hydrogen it is 2. So it is a 3 pair of eclipsing interaction in the above of the ring, and 3 pair of eclipsing interaction present lower in the ring. And due to this eclipsing interaction, the energy of this particular cyclopropane molecule is 27 kilocal per mole. Okay, now let us talk about cyclobutane in brief. So cyclobutane, as you know, there is the four-member carbon ring. It is called cyclobutane, and here this particular ring also contains heavily angled strain due to the fact because this particular bond is 90 degree, and the usual sp3 carbon bond is 109.28 degrees. So due to this sudden dip of the bond angle, so this also be reactive, but not as such reactive as the previous cyclopropane one, because here the angle strain is little bit of lesser than the cyclopropane moiety. Okay, and this particular cyclobutane structure is also face eclipsing strain, like for the case of all hydrogen, they contain the eclipsing strain, and total 8 pairs of eclipsing strain present in the butane molecule. And due to this, cyclobutane are not present in the planar formation, it is present in the Packard formation. And this is the most stable conformer of cyclobutane, where these particular two carbon are present in the above of the plane, and these two particular carbon center present in the below of the plane. And due to this arrangement, actually what happened in this particular eclipsing interaction has been decreased so much, and that's why this particular Packard form is the most stable conformer. Now if we check about the reactivity, so you can find that this particular site are actually much more strain free, and that's why bulky reagents are attacked from this particular site, and the carbonyl will go in the lower site. Okay, and here in this particular deep area or the valley area, here what happened that this particular having little kind of strain there, so bulky reagent won't approach from this particular site. So the small reagents such as NABH4, the hydride donor, these are actually attacked from this particular site, and this particular carbonyl will go upward direction. So due to this Packard form, this type of reactivity has been observed. But in the case of cyclopropane, there is a no stabilized structure was present, and that's why there has been no this type of reactivity or the regioselectivity trend there. Okay. Now let us talk about the another interesting thing, that is the cyclopentane. So cyclopentane is a the carbon-carbon ring formation, or 5 carbon ring formation is there. But here you can see that angle strain is very less, because the usual angle is 109 degree for the case of sp3 carbon center, but here it is 108 degree. So there is a very lesser uh, angle strain present here, so it will be much more stable. However, this particular ring also having 10 eclipsing strain, and to reduce this eclipsing strain, it is present in this particular open envelope form. This is the most stable conformer of cyclopropane. So here this particular 4 carbon are present in the plane of paper, whereas this particular carbon are present above of the plane of paper, and that's why actually it is eliminate the steric eclipsing strain or steric repulsion, and it is present like this. And due to present like this, it also have certain unique reactivity. Like here, if any substituent present here, you can find that this particular area is much more wider, and that's why bulky reagent like L selectrite is attacked from this particular side, whereas the small reagent attack from the more hindered side, that is the present of NaBH4. So with this, we have to end this particular lecture. In the next lecture, we are talking about cyclohexanes and decalines. So it will be a very vast lecture. So please be with there, and we have to end this particular class. So thank you.